All right, so we are now recording. Okay, recording. All right, so I'm going to share the screen. So let's go to the virtual machine. All right, so basically, we open the terminal. So we're here, and the issue is that we want to take a look at some exploits, right? So we want to go in. So you should be seeing the VM. I'm navigating to the Snort folder, right? And I'm here, and then we can go into rules. All right, and you have all the rules there. We want to take a look at the exploits rules. So we are going to do cat exploit rules. And there we have our rules. However, there's too many of these to kind of look through. So in particular, then there's three of interest, right? The no-ops that we were talking about with Joey that he wanted to do on Tuesday, and then there's the two ones, the ntalkd and what was the other one? ntalkd and mountd, I think. Right, so let's look up ntalkd. So I'm going to do a grep here for ntalkd. All right, and there we have, basically there's just one, right? So because this is my cat there, so you guys can see that that is the alert. So the alert is a UDP, the destination port 518. So you can see it's UDP over here. You can see it's to the 518, right? And it is exploit ntalkd basic. And the content is this one, right? So we want to trigger that alert. Okay, so then we have to go, first of all, we're going to go into our, we want to start a new terminal. So let's call this one, let's start the command, right?
Actually makes the pins stick out of the silver part, so if you can imagine.
All right, so please mute your microphones there. So I'm going to go into so we need to start Snort first. I'm just going to get the command for that. All right, so the command should be, sudo, okay, that's already there, snort -q -a console, and then -i ENS33, and then -c, and then etc snort dot configuration. Okay, so that should be it, right? All right, so it's listening on there. Now the issue is that we need another terminal here. Let's say I'm going to navigate to my desktop where I had some scripts in there. So IPS 454. Right, and I'm going to take a look at my general code, right? So this is the one that we were kind of working through on Monday. Okay, so to run this script, I'm going to do sudo python 3, and then this one is called general, I think, general.py. All right, I sent 10 packets. I'm going to look in the Snort machine, and basically it's what we were doing before, right? So we did, my own PNW, the attack that we were working on Tuesday. So today we want to look at the exploit one. So I'm going to go over here, And we're going to just modify this script. So I'm going to do nano. Okay. I'm going to take out some of this, right? So I'm going to take out some of these parts here. All right. And what I need to do is I need to construct, I don't need to send 10 packets. One should be enough. I'm going to change this name to exploit right there. And that way I can modify this one as well to exploit. All right. So now the question is, I need to get the parameters right on this one, right? So that has been what we're trying to do. So do it clear. All right, so we need to go back to the alert that we have already, right? ntalkd. I want to print this one out. So it's got to be easy things. It's got to be a UDP and destination port 518. So let's go back. It's already UDP. So it's already UDP, and then we're going to change this to 518. All right. Now, as you know, one of the main issues is this one, the payload. So, and then we concatenate the packet as usual and send it out, right? So then we need to go back to the description of the alert, and let's take a look. So here again, let's get UDP, that's correct, 518. We want to trigger exploit ntalkd. Remember, it has to be an exact match. And the content is this. These are all hexadecimal because remember, basically, this is a type of buffer overflow. So from your 450 class, this should be familiar to you when you're sending hexadecimal shell code. So we've got here, basically all that's left is to plug in these values, right? The 0, 1, 0, 3, and so on. So we're going to go into the script itself. Go into the script here. And this is where we need to type up the ntalkd. So that's, again, 0, it's X. This indicates that it's hexadecimal, so 0, 1, because it's, that type of shell code. And then, so it's a 0, 1, 0, 3. And then there's 5 0 zeros. So 0, 0. And correct me if you see anything that I mistyped, please. So that's 3, 4, 5. All right, and then after that we have 1, 2, 3, 4, 5. Then we have a 0, 1. Okay, 0, 1. 0, 1. Now, what I'm going to do is I'm actually, because I want this to be a little bit more readable, I'm just going to say X1 here. And then this one's going to be X2, and it's just going to be the rest of it. So here it would be, and I'm going to use single quotes here, just, instead of double quotes. Shouldn't make a difference. All right, and then here now, after the 0, 1, we've got a 0, 0. So obviously I'm going to concatenate these. So I have a 0, 0. Then after that, there is 2 0, 2s. 2 0, 2s. And finally, there is a EX E8. So remember, from 450, all of these would have specific value as shell code or hex, etc., so that you're trying to basically do an attack. Okay, so here we have the two of them, and now we're going to piece them together just by doing x equal x1, lowercase, so x, all right, so this should be x equal x1 plus x2. All right, and then we can send that payload as X. And this has been the issue that we had. So if I run this just like this, it was just like the previous one. Now, one thing I want to do also is I want to print out the content of this. So I'm going to do a print here. And I want to see what happens to this after I, after I kind of load it into this, right? Into this. So I'm going to do a print on raw C. I just want to take a look at what C looks like to see if it looks like this. All right. So that's one thing I want to try. So I do Control X, Y. All right. If I didn't make any mistakes, it should trigger, or it should run. So you can see I sent it, right? I sent it. It's 00, 02, 02, 0x3, XA8. Okay. Now, if I look at the 02, 02, 02, after that, it should be EB, right? Or sorry, E8. It should be E8, but in this case, it's actually X3 and X8. So it changed it a little bit. Okay, so if we look then at the snort, we take a look and we had that my own PNW, but we don't have the thing that we want, which is ntalkd. We were not able to trigger that alert. So this is where we were on Tuesday, and basically it seems that it's something with the encoding, right? So if you take a look at here, if we go back to the code, it seems to be something with the encoding because this last part is not what I typed initially. So it's not really what's in the payload. And this kind of illustrates that this is an exact match. So then what we can do is, what I was talking about on Tuesday was I was trying to do things like this, hex, etc., to change the encoding. I ended up trying adding this, which I know some students try like making it a string, etc. This is just making it a byte array. All right, so that this kind of just changes the formatting of it a little bit. So now let's take a look. So hopefully this now will be XE8. So I'm going to do Control X, Y. I'm going to run it. And if you look, the last one now is in fact XE8. XE8, which is the one that I type. So then now we go into the alerts, which is this screen here, and you can see now in the one of the alerts is actually the alert that we want because we wanted to trigger exploit ntalkd. Does that make sense, guys? Any questions? And as you can see, it was pretty straightforward. Actually, we were very close, but it just needed to be a. It's a good thing because it shows us that snort is. Yes, exactly. So as someone is asking, basically all we had to do is add that little b in front of the string, and it was nothing more than an encoding issue. Okay, it was you saw that. And like I showed in the illustration, we go back to the script. When we run it here, see this one says 002 XE8. This one says 002 C3 XA8. So it was actually, without the B, it was encoding it in a different way. What was going in the packet was not the exact string that's in the alert of snort. And once again, this proves that snort is very much a signature-based system, right? It has to be an exact match. Now the other one, so now we want to take a look at the other one. So I'm going to go back into the alerts here, and now I'm going to do, I'm going to clear this actually. I'm just going to do a clear. And then now I'm going to do exploits, but I'm going to grep the other one, the other exploit, which I believe was mount D, another type of overflow. So mount D. And there you go. There's 3 of these, actually. So you would have to make 3 individual attacks, right? So we can pick one of these. I think the one that I gave you is the first one, if I remember correctly, right? So what would you have to do? Kind of the same thing. It's a UDP. This time it's looking for UDP packets with a destination of 635 to trigger the Linux mount D overflow, and the content would need to be this. If you notice, there aren't any more fields, which makes these kind of convenient. So we can go ahead. So first of all, UDP 635. So we're going to go into the script here. So this is going to be UDP 635. 635. And now we're going to take the same approach. So we need to, in theory, if this works correctly, all we would have to do is change the content again. So I'm going to go here. And I'm going to do, all right, so it should be the caret. So it's got a caret symbol there. And then X80. Or is that a, what is that? No, that's a B0, right? That's not an 8. Okay, B0 then. B0, then it's going to be B0, 0289. 89. Then 06FE. Then we're going to do, what is the next one? C8. 8. Then it's 89F. 89F. Then we have a 04. Okay, and I'm going to just do the rest and the other one. So then after 89F and 04, we can do B0. Oops, I'm missing an X there. B0. 06. And finally, 89F. 89F. There we go. All right, so hopefully we got the indication for byte, right, for the formatting. Now we are going to launch this. So let's save it. Okay, we're going to run it. Do a clear here. Okay. Run. All right, so B00689F. Okay, all that looks similar. So now the question is, did it trigger the mount D alert? And so here we had ntalkd. And then this is bad traffic. Yeah, so here it is. So you can see mount D is right here. And so that detected the mount D overflow attack. Does that make sense, guys? Any questions? All right, and that's pretty much, you know, that was really the only, the problem with it was trying to get that encoding. You know, hexadecimals are always going to be a challenge because you know, it's if you remember from 450, right? We had to put in that shell code, and that shell code is technically the machine code that goes in the computer, and that's what you'll see in the packet when people are doing the buffer overflow attacks. All right, the other problems that we were trying to look at, which were actually pretty interesting, were the ones related to the no-op, right? So as we said, what is the no-op? Well, that's something that you should know from ITS 450. It is basically, you know, a no-op sled, right? So whenever you jump in the buffer overflow attack, right, you jump with the address to somewhere in the stack, you're going to hit that NOP sled, and then the NOP sled just means the CPU should move to the next instruction in the stack and so on until hopefully you get to the shell code that you want to run. And so it makes sense, in fact, to find alerts that are governed around no-ops, right? That are governed around no-ops. So in this case, let's try that. So I'm gonna try, still in the exploits. This one's just an interesting one, I would think. So let's do grep here. And then usually it'll look like this, right? So in the alert, we're just looking for ones that have no-ops. So I'm gonna hit this, and now you can see there's actually one, and two, right? So this is, I think, what Joey was trying to do. So if you notice, to get this, let's look at the first one. So the first one says TCP 22 no-op, right? Now you can see that there's this flow. This flow is important, so we're going to have to think about what that is. Now the content seems pretty straightforward, actually. The content just says, you know, 90s, right? And then there is pretty much nothing else. So that's why I like this one. However, this flow, as it turns out, is pretty important. The other one, alert, if we look at it, it's TCP destination port 22. It's called Sniffit overflow. This one is actually, the flow is stateless. So that kind of leads you to think, okay, one is established to server, the other one is stateless. So what does that mean? The other thing is the flags, right? So this flag A+, that's the flags that you set in the TCP packet, the TCP header for ACK, right? So SYN, ACK, all of those. So that just means ACK. The plus just means it could have more than that, but definitely ACK must be there at least. And then the content is actually a little bit more complex. There was a from here and something else. What I did is I just deleted that part to keep it simpler. So if you look, there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 no-ops, okay? So there's 11 no-ops. There was something in front, like another hex and a from, so there was a string combined with a binary. So just to simplify this a little bit, all I did is I deleted the front part. So if you guys want to repeat this exercise as one of your rules, just delete that part over there. Notice that it says no case, which is good because it doesn't care about if something is uppercase or lowercase. That's not going to affect us. It means that the flow is stateless. So that basically means that it doesn't need to have a TCP, basically you don't have to have a TCP session established, right? And that's actually a problem in this one, right? So from to server, established, etc. What that implies is that this is only going to look at established TCP connections. So because right now we don't have an established TCP connection, it's really not going to work. However, how you could do this is when, you guys already know from TCP session hijacking how that works, right? In TCP session hijacking, you guys established a connection, you hijacked it. So all you need to have is what? The source IP, destination IP, source port, destination port, and the TCP sequence numbers, right? And then that means it's part of a session, it's part of an established TCP connection. That's what this implies. So you would need to do all of that for it to work. So I kind of just went with this one instead because this one flow is stateless. So I don't need to have it will trigger the alert. So that's really all that's needed here, since I simplified the payload a little bit, I just need 11 no-ops. I'm going to need a TCP flag that is ACK. And if you look at this rule, there's nothing else in it, right? So the destination port is 25. So then let's go ahead. Let's see if we can't trigger the so-called Sniffit overflow. All right, so the way to do that, we can go back to our script here. So I'm going to do this. And now I'm just going to create, it's only no-ops. It's 11 of them. So I'm going to create no-op. And I'm going to say, now I'm going to do that B thing, right? So just to make sure everything works, I'm going to do X90, right? That's the equivalent. And, you know, in Python, you can do things like this. So that just makes it 11 times. So now that I have that, I can plug it here, no-op. And what else? It said that it was a TCP. And it said that it was a 25, I think it was. All right, so if everything is correct, I'm going to try this one, Control X, Y. I'm going to run it. All right, I sent the packet. So let's take a look at the Snort. Okay. So this was the last one, exploit mount D. That's none of these. Okay, so it did not trigger. So let's go back then. What did I miss? One, two, three, four, 5, 6, 7, 8, 9, 10. There's 11. TCP 25. Oh, the flags. Okay, I didn't do the flags. Okay, so then I need to go into the code again. So how did we do flags in the TCP headers? Do you guys remember? Wasn't it flags equal A maybe? Something like that. Flags equal, okay. So let's try that then. Flags equal A, right? It said it was in an ACK. A for ACK, okay. So let's go ahead and try that one now. So I'm going to do Control X, Y. Send it again. Send one packet out. Go back to the Snort machine. And there it is. Exploit Sniffit overflow. So Sniffit, if you look, exploit Sniffit overflow. We look at the alert, which is this one. You can see it there. Exploit Sniffit overflow. All right, and that's basically, you know, one of the things that we were working on Tuesday, plus the other two exploits. Are there any questions? All right, so that's basically your alert. So I think, as I said, you have your exploits, you have your DOS, you have your scan, and then you just have to create the other two, or use, figure out something. But you need to have 5 different families. What that means, you grab from the exploit.rules, DDoS.rules, scan.rules, and the other two have to come from 2 other files, basically. Okay. All right. So that's so certainly scapy is extremely powerful in everything that you can do, and hopefully you've seen how the alert mechanism works in Snort. All right. So I'm not seeing any questions.
Actually, I had one.
Go ahead. So ask me.
I was trying to do the other two that we have to do on our own, where you pick your own basically, and I tried changing the D port and the content, and I couldn't get it to work. Is there anything else we have to possibly change?
So which rule is it? So you have to tell me what file you're in and give me like a keyword or something so I can look it up. You know what I mean?
Right. Let me see if I could find it because I was doing it earlier. I think it was under FTP rules. Let me
tp.rule.
see. Hold on. Yeah, I don't remember which one I was doing specifically, but for example, I would take like the content would say like XMKD, and then I'd change the D port to 21.
Hold on. The content would say that? You're sure it says exactly that?
Right. So it'd say content and then quotes XMKD,
XM in lowercase?
uppercase.
XMKD. All right. So is it this one?
Yeah.
Okay. So this one, let's see, it's a TCP, destination port 21. The message is this. See, this one has a challenge because you have to have an established session for it. You know what I just said just now?
Mm-hmm.
So the only way to get this one to work would be to piggyback off of the TCP session hijacking example. However,
Okay.
there's something that you can do, right? You know what you can do? You can go into the file and just delete this or change it to stateless.
Okay. So in the file we create, would we change the state to stateless, or in the actual source file?
Go to Snort itself.
Okay.
Snort itself, right? And you can just change the flow from to server established and change it to stateless.
Okay.
Does that make sense?
I think so, yeah.
And that way you don't have to have a three-way handshake and everything, because otherwise you'll need sequence.
Right.
And so that's, you know, more work. And so that's kind of the idea, right? So you have hundreds of possibilities. Try to find simple ones. Okay.
Okay.
You can take another one of the well, we did some ICMP ones, right? We did ICMP. We did, I can't remember what else. Oh, you can also create your own rules. That's perfectly fine as one rule.
Okay.
All right. Any other questions? So everyone's in good shape with this one then? So I'm not hearing any questions.
I had a question about the report.
Go ahead, please.
So for each problem, you want us to show our code, us running the program, and then the alert?
Yeah, so you have to, so it's like this. You have to tell me, I want to trigger this alert in Snort from this family, right? Let's say you picked ICMP, right? And then you say, I went to the ICMP file, and then here, you know, the screenshot, just kind of like what I have here, right? This is the alert that I'm going to trigger. So it's going to, so I know that I need to look for FT, XMKD, what, you know, whatever it is. Just show me the you can modify the alerts, as I said, like with this one, just show it as stateless, keep it simple. And then once you've done that, you show the code, right? This is my script as I did. You run it, it shows that a little packet was sent out, and then you show on the Snort machine the actual alert, right? So here you can see it also says FTP XMKD overflow attempt.
Okay, thank you.
All right. Good. Okay, any other questions? So if there's no questions, we can start talking about the firewalls lab. Although I'm not assigning it yet, I'm not going to assign any homework during spring break. We will start. So let's actually go to the calendar. So let's go here. And if you look at the calendar, you can see here, I've updated the calendar, so let's take a look. So basically, right, so we're doing this right now, and then when we come back, we got spring break, so the homework is due on March the 13th. When we come back on the 23rd, we'll just focus on firewalls. So we have really just two topics left, which are firewalls and VPNs. Right, so those are two major labs, obviously, to wrap up the topics. So we will start, but that lab will start on the 23rd. However, we can start talking about it today if there are no additional questions on the current lab.